Okay, hi everybody, I'm Rainer. I'm a dev at Microsoft, but this is absolutely not like how Microsoft thinks about semantic versioning. This is my rant. I can't push it on anybody else. In contrast with the measured approach that we just saw about, hey, this is a tool and it has pros and cons, this is a religious talk, and my religion is I don't think semantic versioning is worth very much, but we'll get to that. We'll get to why in a second. So, what's the deal with versioning in general? The deal is things change, right? You have bugs to fix, you have new features to add, you have big changes that you want to make. And your application is built on libraries that have bugs to fix and things that they need to add and things that they need to change. And that's built on an OS, and libraries depend on other libraries, and everybody has all of these things. So how do you define, like, I need this piece of software at this version? Well, you define versions for software, and then you say, okay, at this version, that is this defined thing. What's a version? SemVer.org presents a specification called semantic versioning. They're at version 2.0. It's a formal specification. And the idea is that it will help you solve all of these kind of versioning problems. So what is that spec? It's three things. Number one, it's a way to describe what a version is in terms of, like, I have a string of text. What is it, a version, and what does that version mean? Number two, it's some sorting rules for those version strings, right? If it fits into that version, there can be a set of rules to sort it. And number three, it's a definition for when to change the various fields in your version number. So let's crack open an example. This is a big example. Not every version needs to be this complicated, but this is all a bunch of the stuff that's in the spec. So, a bunch of stuff going on here, but the main thing is that we've got a major number, a minor number, and a patch number, right? 3 integers separated by dots. That's a version number, and that's all that's required. In addition, the specification allows some optional options. There is a hyphen and then a pre-release set of things, and this is actually something that can be broken down into individual identifiers. So here we got pre-1, 2019, 7, and 1 are the individual fields in the pre-release part of this version. And those can be either numbers, like the date part of that, or they can be alphanumeric, like the first pre-1 part there. Then you can optionally, again, have a plus and build metadata, and that is allowed to have the same kind of dot-separated identifiers. The main thing we'll get to is in the sorting rules that we're about to discuss, the build metadata is ignored. So that's a great place to put, like, the SHA hash of the git commit from which you built this version of the software. It's something that is useful to know for people, but you can't sort by it because it's a hash. So, sorting rules. I think of them as sorting rules. The spec describes them as precedence rules. So how do you sort versions? By major version, 5.0 is bigger than 4.0. By minor version, 5.1 is bigger than 5.0. By patch, 5.1.1 is bigger than 5.1.0. All of this totally makes sense, right? Pre-release gets a little complicated. If there's no pre-release, it's a higher version, right? So you can say 1.0.0-pre, and that's the pre-release version of 1.0, or you could say -RC for your release candidate build, things like that. And then when 1.0.0 comes out, that is a higher version. If you've got pre-release fields, then it sorts by those identifiers. Left to right, the number of identifiers comes into play. It's an alphabetical sort if there's anything in that field that is not a number. It's a numerical sort if there's a field that is a number. So you can do things like that date that I just showed, and it'll sort correctly by date. You won't get, like, 31 sorts before 4, that kind of thing. Okay, so I promised that this was an angry rant about versioning. All that stuff that I just described, I'm totally cool with. I got no complaints about that sort of thing. I do have a nit to pick, which is that Windows, since the dawn of time, has had a 4-part version field, major, minor, build, revision. And there is in every .dll or .exe file a field in the actual like the Windows PE file format that when Windows understands what a DLL or what a exe is, that handles that 4-part version number. But honestly, you don't need that 4th part for anything, and this is a nicer number in basically all these other ways. So the PE specification includes a string field as well. So just treat that as canonical, stuff whatever of it you can in that 4-part version, and call it good. So the part I don't like about SemVer is the other part of the spec, which is I have a change I want to make. What do I do to the version number, right? I've got something that I need to do to my software, and then I'm going to release a new version of the package. What version is that? And the rules, as described in the spec, are pretty straightforward. You increment the major version and reset the minor and build version, or patch version, when you make a breaking change to the public API. And if you add something to the public API, but don't break any of the existing functionality, you add a new method, something like that, then you increment the minor version and reset the patch version. And then the patch version then signifies backward compatible bug fixes, right? You didn't change anything in the public API, but it now behaves differently. Okay, so all that's great. No. And the main problem is that software is hard. So a bunch of those things are easy to describe until you get to the point of asking, okay, what's a public API? And as .NET developers, there's a straightforward answer to that, which is it's your public classes, their public methods and properties and things like that. And that's true. If you change some of that, that could break somebody that is depending on your application. And they could update your library, and then their software doesn't compile. That's a problem, right? Absolutely. But what about behavior? A compiler is a piece of software that takes in a bunch of source files and emits an error, and if there's no error, it emits some DLLs and various other things. But I certainly argue that it's a breaking change to swap the Visual Basic compiler and the C# compiler, even though they have that same interface, right? You take in a list of files and some references, and then you emit an output. If you suddenly start emitting an error all the time, hey, that's a big change. People are going to want to know about it, right? And so that gets to the point of, okay, define compatible. What does compatible mean, right? Is it their software continues to compile? That's one reasonable definition of compatible, but then you get into that compiler swap situation. It's like, oh yeah, like their software continues to compile, it just always fails at runtime. That's an important thing that you would want to know about as a consumer of a library. Hey, nothing works anymore. So that's not a good definition. In addition, there's some real weird subtleties about that. Like, has anyone ever shipped a library that has a public type, a public class, and then that class wasn't sealed? If so, adding a method to that public unsealed class could be a breaking change if someone inherits from it, because then they're not implementing that. So that could be a problem. So does compatible bug fix mean their code continues to run without error? That's the idealized thing, right? Nothing changed, nothing bad changed. There's a couple of big problems with that. One of them is security fixes. Suppose you are using a library to manage your connections to a database, and it just wasn't checking the security of the connection. And then you say, hey, library author, I would like to report a bug. Or more importantly, somebody else says, hey, it's not validating the security of the connection to the database. And they say, oh, it was supposed to be doing that all along. It's clearly a bug fix to enable that. And then you update to that bug fix, and now you can't connect to your database because of a misconfiguration on your side, right? that's a breaking change. It's probably the one that we want to do, right? We want security fixes. We want to be in a secure state. But if you're going with the SemVer spec and hoping that like, oh, it's just a bug fix update, I can apply it any time. Like, I'll just push it directly to production, no problem. Well, now you brought your whole site down, right? So it's the kind of thing where you gotta worry about that. Another situation that's super common is working around a bug in a library. Suppose you're in a really good case where you're like, oh, I found a bug in a library. I reported it to the maintainers of that library. They said, oh, yes, that's definitely a bug. I see what it is. I've got an if statement, and it should be if not foo, but it actually says if foo, right? I've written that bug 100 times, and so has everybody else. And they say, oh, okay, oops, sorry, I'm gonna fix that in the next patch release. But they say, for now, just invert it on your side when you call it in, and then like you'll be unblocked, you can work around this issue, and everything's fine. So you do that. Hopefully you check it in with a comment like this that's like, this is a workaround for the bug, this is not correct. But you're still calling something with the wrong parameter. So then you update, you get the fix, they added that exclamation point and fixed all their problems. And now your code is broken because you were working around that fix. So is that a breaking change? It was not doing what it was documented to do before. Now it is doing what it was documented to do. That's a bug fix. That's the definition of a bug fix. And especially for something where it's like this, this situation, then that's a easy change to make, but it's a breaking change if someone has been working around it. And this is a piece where working at Microsoft on big projects like Windows and SQL Server and Visual Studio and .NET has definitely colored my opinions, which is if anyone anywhere can possibly observe the behavior of your system, they will take a dependency on it, and then they will get broken on it. Even when you think like, oh, it was never supposed to work like that, it was only ever working like that because of a mistake, well, that you can't fix that mistake, it's a breaking change in many cases. Another case that's interesting is the SemVer.org site has this example of how do you do breaking changes? And one of the thing that they recommend is you figure out what you want to remove, you implement the replacement for it as a new feature. That's a new feature, great. Then you mark the old API as deprecated, and the idea is you're supposed to have at least one feature level release that has both enabled side by side, but has a pointer from the old way to the new way. So in .NET we have this obsolete attribute where you can pass in a string and you can say, don't use foo.bar, instead use foo.as because of whatever. And then in the next major version, you can go in and you can remove all of your obsolete attributes, or all of your methods that were marked with obsolete attributes. Okay, awesome, great. Here's a problem. The problem is warnings as errors. When you add an obsolete attribute, anything that calls that starts generating a warning at the compiler level. If the person who is using your library has warnings as errors turned on, you just broke their build. A break in their build is definitely a public API change and is definitely a major version worthy. So in order to follow what the spec recommends, that requires 2 major releases, one to add the obsolete attribute to get people to move, and then another to do it. And that's something that's totally doable, but it kind of pushes things forward. And this is another problem with the kind of idea of like, oh, this version change means there's a breaking change. Cool, how bad of a breaking change, right? If it's something like this where you should have been silencing these warnings all along, or if it's I removed an API that I literally believe no one has ever used, but it was part of my public API, those are maybe no big deal, right? Maybe no one would even notice if you snuck it in as a patch release. But it's technically a breaking change. Also, literally everyone who calls my library will now have to rewrite all of their code that uses my library is one major change away, right? So you don't get a ton of information out of that. And now you're saying, oh, Rainer, you're so smart. You found all these problems that no one has ever noticed before. Not only am I not the only one who has noticed these things, right? The spec itself talks about a lot of these things. It talks about in the FAQ that's attached to the spec on SemVer.org, without compliance to some sort of formal specification, version numbers are essentially useless for dependency management. I think they're so close, they can just delete the first half of that sentence, and then they'd be right. Version numbers are pretty much useless for dependency management. And the spec also says, what are these version numbers for? They're there to communicate your intentions to the users of your software. Right? So that it's not a technical solution, it's a communication solution. And the problem is that your intentions, as in a lot of things, don't always matter. Just like if you offend someone because you said something that you didn't realize was offensive for whatever reason, it doesn't matter that you didn't intend it offensively, you didn't mean to be sexist or whatever, right? What matters is that that is the way it came across. That was the effects. The effects are what matter, not necessarily the intention. So this is a similar situation, right? If you broke somebody's library, even if you meant to fix a thing that never should have behaved that way in the first place, well, that's bad. And the spec also goes on to say, well, of course you're a responsible developer, so you're going to go on and you're going to verify that any updates still meet your needs. And, yeah. But notice how that sentence in the official FAQ does not mention only when the major version field changes, right? It's not, because anything could break you. You could have a bug. You could be accidentally depending on a bug. You could be accidentally depending on performance characteristics of the library that everybody thought was purely internal. So when you take an update, you still got to run all your tests, all your unit tests, all your functional tests. You got to figure out, hey, does this thing still do what it is, regardless of what level? That patch level can be informative, right? It does provide some communication functionality, but not a ton. So I don't have like a fix for this. The problem is that software is hard, and versioning is part of software, and it itself is a hard sub-problem within software. So you have to test stuff, and you have to take breaks and maybe go off and look at a lake sometimes, because software is hard. Questions? Invitations to rant further? Cool?